This is 12-6, segment relationships in circles. Try the warm-up and hit play when you're ready to see the answers. So when solving the equations for 1 and 2, I got x is 4 and x is 48. For number 3, since the tangents were meeting at the same point outside of the circle, then those segments are congruent to each other. So I set them equal to each other, and I solved for y, I plugged that back in so that I could get BC, which was 14 units. Okay, let's take a look at our first theorem, chord-chord product theorem. If two chords intersect in the interior of a circle, then the products of the lengths of the segments of the chords are equal. So what I'm saying is if they're meeting on the inside, then AE times EB is equal to CE times ED, so the parts of the segments. And product means multiply. So here we have two chords meeting inside, so it's going to be chord-chord product theorem. So that means 14 times x is equal to 7 times 10. So we have 14x equals 70. So x is 5. And then from there we need find the value of x in the length of each chord. So the full length of the chord, well, FE we already know that the length of the chord, now we're not multiplying anymore, we're just trying to find the length. It was 7 and 10, so that's 17 units. And then the other chord, GH, is going to be equal to 14 plus the 5 that we just figured out, 14 plus x. So GH is 19. Example 2. The art department is contracted to construct a wooden moon for a play. One of the artists creates a sketch of what it needs to look like by drawing a chord in its perpendicular bisector. Find the diameter of the circle used to draw the outer edge of the moon. Okay, so we know a couple things. We know that these are congruent, so they must each be 9 inches. And I know that the other piece that's missing is the diameter minus the 8 we've already used. So when I do chord-chord product theorem, I'll have 8 times d minus 8 is equal to 9 times 9. And so 8, we can distribute that if you want. 8d minus 64 is equal to 81. Add 64, so we get 8d is equal to 145. Divide both sides by 8, so that d is equal to 18.125, or 18 1/8, however you want to think about that, inches. So remember that a secant segment would be like PM, the full secant. And now we're going to talk about an external secant segment, which is just the external piece of it. So in this case, like NM would be an external because it's the outside piece of the secant. Okay, with that being said, now we have secant-secant product theorem. This says if two secants intersect in the exterior of a circle, so they're intersecting outside of the circle, so here they are, they're intersecting at point E, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. And it's summed up nicely right here. Whole times outside equals whole times outside. So the whole secant AE times the outside BE is equal to the whole secant CE times the outside DE. So secant-secant product theorem, in summary, is whole times outside equals whole times outside. So here we have a secant-secant, so I'm going to use secant-secant product theorem, which is the whole segment, x plus 8, times the exterior piece, 8, I'll put that there for distributing reasons, is equal to the whole segment, 9 plus 7, which is 16, times the exterior piece, which is 7. And you can distribute, or you can just divide by 8 right away. It's up to you. So if I choose to distribute, I get 8x plus 64 is equal to 16 times 7, 70 and 42, which is 112, minus 64. So 8x equals 48. Divide by 8, and x is 6. So it says find the value of x and the length of each segment. So I found x, and I have to do each segment. So GE is my first segment, and that's going to be 8 plus x, which is 8 plus 6. So GE is 14. And then I also need to find DE, which we knew right away was 9 plus 7. So DE is 16. Remember that a tangent is a segment with one endpoint on the circle. So now let's take a look at secant tangent product theorem. So secant tangent product theorem basically says that if you have a secant and a tangent, then it's going to be the whole of the secant times the outside, like we just did before, is equal to the tangent squared. So let's just focus on this wording to get us through this next problem. The whole times outside equals tangent squared. So we have my secant LM, we have the tangent LK, and so we're saying that the whole, which is 15 plus 5, times the outside, which is 5, is equal to the tangent x squared. So let's simplify this. Parentheses first, 20 times 5 equals x squared. 100 equals x squared. Well, to cancel the x squared, we would take the square root. Let's cross that out. And so we get 10 equals x. So x is 10. That's all they wanted us to find, the value of x. If we need to know LM, it would be 20.